Jupiter is not a planet, not in any sense that feels familiar. It's a monster. 1,300 Earths fit inside it. Its storm, the Great Red Spot, has been raging for 350 years, and its gravity is so powerful it acts as a shield for the entire inner solar system, catching asteroids and comets that would otherwise hit Earth. Now, imagine we remove Jupiter and put Earth in its place. 778 million kilometers from the Sun, alone, in the dark. What happens next will surprise you. Before we continue, your question for today. If Earth replaced Jupiter, do you think life exists right now in Europa's subsurface ocean? Drop your answer in the comments. New here? Subscribe. This is where we move planets with real science. Jupiter sits at 778 million kilometers from the Sun, 5 times further than Earth's current position. At that distance, Earth receives only 4% of the solar energy it gets today. Not half, not a quarter, 4%. The Sun from Jupiter's orbit doesn't look like the Sun we know. It looks like a very bright star, distant, cold, indifferent. Surface temperatures on Earth drop immediately. Within years, average global temperature plunges past -100 degrees Celsius. Within decades, the atmosphere itself begins to freeze. Nitrogen, which makes up 78% of our air, liquefies at -196 degrees. At Jupiter's distance, Earth doesn't just get cold, the air itself falls to the ground. Liquid nitrogen pooling in the valleys, oxygen crystallizing on mountain peaks. A planet that was once alive, breathing its last in silence. Let's paint the picture precisely. Within a decade of arriving at Jupiter's orbit, the oceans freeze completely. Not the surface, not partially, completely. All 1.335 billion cubic kilometers of ocean water, solid ice. The Amazon River, frozen mid-flow. The Sahara, buried under frozen atmosphere. The Mediterranean, a solid block of ice stretching from Spain to Egypt. And the sound? Silence. No wind, because the atmosphere has frozen and fallen. No waves, because the ocean is solid. No rain, because there's no water vapor left in the air. The Earth at Jupiter's orbit isn't dramatically destroyed, it's mummified, perfectly preserved. Every city, every forest, every ocean, frozen in place, exactly as it was the moment it left the warmth of the sun. But here's where the story gets more complex and more important. By moving Earth to Jupiter's position, we've done something far more dangerous than just making our planet cold. We've removed Jupiter from the solar system, and Jupiter, as it turns out, is the reason Earth survived long enough for life to develop. Jupiter's massive gravity acts as a cosmic vacuum cleaner. Asteroids and comets heading toward the inner solar system get captured by Jupiter's gravity well, deflected, absorbed, destroyed. Scientists estimate Jupiter has reduced the rate of large asteroid impacts on Earth by a factor of 1,000. 1,000 times fewer catastrophic impacts. The extinction event that killed the dinosaurs was the exception, not the rule. With Jupiter gone from its position, the asteroid belt becomes destabilized. Rocks that have been in stable orbits for billions of years begin drifting inward, toward where Earth used to be, toward Mars, toward Venus, toward whatever is left of the inner solar system. The cosmic shield is gone, and the bombardment begins. But here's the twist nobody expects. Jupiter has 95 moons, and some of them are more interesting than Earth itself. Europa, Jupiter's 4th largest moon, has a liquid water ocean beneath its frozen surface, more water than all of Earth's oceans combined, kept liquid not by solar heat, but by tidal forces from Jupiter's gravity, flexing and heating the moon's interior. Ganymede, the largest moon in the solar system, is bigger than Mercury. It has its own magnetic field. Io, the most volcanically active body in the solar system, generates constant geothermal heat. In a scenario where Earth is frozen solid at Jupiter's orbit, the moons of Jupiter become the most interesting real estate in the solar system. Europa's subsurface ocean, potentially harboring life right now, becomes humanity's next target. Not Mars, not Venus, Europa. The irony is extraordinary. By moving Earth to Jupiter's position and freezing our home world solid, we might accidentally discover that the best place for life in the outer solar system was orbiting Jupiter all along. Step back. Look at what we've learned from this thought experiment. Earth at Jupiter's orbit freezes within decades. The atmosphere falls to the ground. The oceans become solid ice. But the moons of Jupiter, heated by tidal forces rather than sunlight, remain liquid, active, potentially alive. This tells us something profound about how we search for life in the universe. We assume life needs a star, needs sunlight, needs warmth from above. But Europa, and moons like it around Saturn, Uranus, Neptune, suggests life might thrive in the dark, far from any star, heated from within, hidden under ice. If that's true, the universe has vastly more habitable real estate than we ever imagined. Not just in the warm zones around stars, but in the dark, cold, distant orbits where gas giants and their moons exist. We've been looking for life in the light, but life might prefer the dark. Jupiter is 778 million kilometers away tonight. You can see it with the naked eye, a steady, bright point of light that doesn't twinkle like a star. And every time a comet or asteroid crosses its path, Jupiter's gravity pulls it in, quietly, invisibly, protecting us. The solar system isn't just a collection of planets orbiting a star, it's a system, every piece in its right place, every giant planet doing a job we barely understand. Move one piece, and everything changes. So the next time you see Jupiter in the sky, don't just see a planet, see the reason you're here, the guardian that never sleeps.